Hey everybody. Today what I want to go through, you can see the title up on the top, an algebra skills review. So what we're going to do is we're going to knock off some rust and get rid of some cobwebs, dealing specifically with some algebra topics. So let's jump right in and make sure that we've got as much time as we can to practice and get back into shape. So take a look at problem 1. I've given you the instruction to simplify. And we should be good that the instruction simplify means write your expression doing as many of the operations as you can, so you're leaving as few operations in there as possible, where everything that you leave is an integer. So we take a look at the expression that was given, and you see there's your big long expression. And we can give that a read, 3x squared minus 5x minus x squared plus 2x plus 4. And we need to simplify that thing. So we're going to do as many operations as we can where everything left is an integer. So let's take a peek. Coming out of grade 9, you should be quite comfortable to be able to recognize like terms. You know, that you have x squareds that I just circled in orange, that you have single x terms that I just circled in blue, and you have constants that I just circled in red. So we should be good to be able to go through and collect those terms. So I'm going to get rid of all those circles. You would never need to write those down. And now we can collect. So I'm going to take my 3x squareds and I'm going to subtract my 1x squared. That is going to give me my 2x squareds. I am then going to take my negative 5x and add on 2x. And you'll notice we get into a little bit of an integer thing there, which I'm hoping that we are quite good at collecting. Look at your green. I lost $5, my minus 5x. I found $2, my positive 2x. Well, if I lose 5 and then I find 2, I'm still down 3 of those x's. And then what's nice, we just have our constant on at the end. There is nothing to collect that with, and there we go. Okay, make one note. Your proper form is the order that I just wrote that in. I'm hoping that you guys are good that what we have is descending order. That is, we finish with the highest power of x in our first term, our next power of x in our second term, and no x's in our last term. So when you see those three, you'll notice they're in descending order, and that is our standard form. That's what we should finish off with. Okay, there we go. First one, making sure that we can collect in order to simplify an expression. Okay, let's jump into something a little bit different. So I want to give you a moment to give problem 2 a read, okay? So I want you to pause the video now and read problem 2. Okay, we're back. So you've read the problem. Each of the following expressions is equivalent to, so that means equal to, that red underlined expression, 3x minus 5y plus z. What you need to do is find the value of each missing numerical coefficient. So if you recall, coefficient talks about the number attached to a variable. It's attached by multiply. So if I just get rid of that purple underline and I blow up the expression in A, I notice that I have this red question mark here, a coefficient on x. I also notice that I have this green question mark here, the coefficient on z. So you have interpreted the question correctly if you figured, okay, I have to find out what number has to be the red question mark and what number has to be the green question mark to get back to that red underlined expression. Okay, now that we made sure that we understand what the problem was asking, I want to give you a moment to try to come up with a solution to that problem. While you were doing this, I do not want you to be concerned at all about the format of your solution. There is going to be plenty of time for us to talk about the language of algebra and all the formatting that needs to go into that. We've already talked about some of it today. This one, make it free problem solving. I don't care what you write down. Your job is just to try to come up with those missing values. Okay, give it a shot. Pause the video now. Okay, we're back. So if you were taking a look, I'm going to use a bunch of colors on this one. But if I was to go through and get rid of all of those underlines and recognize that what I have in my final expression is what I underlined in orange. And what I need to come up with is the question mark and the question mark. Then I can look and see where those question marks are. Let's take a look at the red one first. The red question mark is the coefficient on x. So if I was to tie together my two x terms, if I took this 1x and I collect it with some unknown number of x's, now look back up to the orange underlined expression. It has to result in 3 x's. So if I have 1x plus some other number of x's, I know I have to get 3x. Then I'm hoping through inspection, you might just go, then it's 2. And that red question mark would have to be 2. Maybe it doesn't come through inspection though. Maybe it's a matter where you say, I'm going to build an equation that maybe the 1 in front of the first x plus some unknown amount, the question mark, has to be equal to, remember that word equivalent, 3. And now you can draw back on some of your old algebra skills for solving equations. If I want to isolate my question mark, then to get rid of a plus 1, I minus 1. 3 minus 1 is 2. And there we go. Okay, that gives you a way to go through and try to come up with the solution for the red question mark. Let's check on the green one now. Okay, the green one happens to be a question mark in front of the z. So my other term that has a z in it is my negative 2z. I know that my final expression is 1z. And so you can use inspection. You could say negative 2 plus what gives me 1. And now solve the equation. I don't care how you do it, but make sure that we come up to that green question mark has to be 3. Negative 2 plus 3 gets me to my 1. Okay, I want to leave you with question B now. I think question B becomes a great problem for you to try on your own and see if you can work through some of that algebra problem solving. Okay, pause the video now. We'll come back and we'll confirm our solution. Pause it now. Okay, we're back. So I'm going to stick with the same colors that we did before. We've got the 3 in red, and we got the X in red and the Z in green. I take a look, and I'm looking for my question marks. Well, my first question mark happens to be a blue one. It's in front of my Y. Well, now I got to pay attention to my Y back up in my expression. So I have this Y term and this Y term, and they have to get me back to that Y term. So I could say to myself, 2 plus what gets me to negative 5? Well, if I find $2, what do I have to do to that to lose 5? I need to lose 7. And so hopefully you came up with the coefficient on the Y has to be negative 7. If I stick with the same colors, as I said, well, my green is my Z, my other question mark. And so maybe I can take a peek then and say, well, negative 3Z plus something has to get me to 1Z. Well, what would I add to negative 3 to get up to 1? A 4. Okay, I'm going to zoom out, let you see everything, and hopefully that's what we came up with. Again, I could not care at all about the structure of your solution. For us, it was a little bit of problem solving to knock off some rust. Okay, we talked about format of solution and language of algebra. This is what we're going to jump into now. So take a peek at problem 3. Problem 3 has a very familiar instruction. It says to simplify. We know what simplify means. So let's do every operation we can where all the values we are left with are integers. Okay, I'm going to start getting to the point where we should be good to be able to pause the video and you attempt all of these problems on your own. We come back for confirmation. So let's give A a shot. I want you to pause the video and we'll see how we do. Pause it now. Okay, we're back. So you take a peek, and I'm just going to erase that circle on simplify. I take a look at all the operations in that expression. Look at what I underline in purple here, and look at what I underline in purple here. If I'm going to follow BEDMAS, which is the order I have to do my operations, they would say do the operations inside the brackets. So I have to subtract first and subtract first. My only problem is that in order to subtract those first two things, they would have to be like terms. And they're not like terms, so I can't subtract them. Same thing with the last two terms. So if I can't do the subtraction, then I move on to the next operation. My next operation is addition. And so that says take everything inside the first bracket and add it to everything inside the second bracket. So I'm going to add all my stuff, whatever I can. Well, let's take a look in the first bracket compared to the second bracket. You'll notice you have an x squared term in the first bracket, and you can collect that with the x squared term in the second bracket. So a 5x squared plus a negative x squared. So if I collect a 5 with a negative 1, then I get 4x squareds. I can then collect a negative 9 with a positive 3. If I lose $9 and I find $3, I'm still down 6. And there we go. Hopefully you matched up and we see our reasoning. Okay, we see all we're doing is following BEDMAS and trying to simplify doing as many operations as we can. Okay, let's take a look at B. I want you to give B a shot on your own. Okay, pause the video now. Okay, we're back. So you take a look, you notice to follow BEDMAS, we have to collect on the inside. We run into the exact same problem we had before. We cannot collect like terms, so we move to the next operation. You notice that you have subtraction in between your brackets. So take everything from the first bracket and subtract everything from the second bracket. You notice again, you have an M term in both brackets. So I am going to take 2m and subtract 4m. So if I take 2m and I subtract 4m, then I have negative 2m. Here comes your trap one. Now what I need to do is take a negative n and subtract a negative 8n. Well, if I subtract negative 8n, I'm subtracting a negative. That means I make it more positive. So I really need to put together a negative n plus 8n. And if I lose $1 and then I find 8, I am up 7, and there's my final expression. Okay, I want to give you a quick rundown on an alternate way to tackle B. I don't think that this is a better way, but it could be a way that you're walking into our course with. That is, you take a look at B, and you may have been taught that when you see a minus in between your two brackets like that, view it, that minus right in between, view it as if there was a -1 out in front of the bracket. And what you're doing then is you're putting in a multiplication operation. And you may have been taught to now expand that -1 into your bracket. That's okay. I don't think it's as good as that purple method, but that's okay. So maybe what you ended up doing was expanding brackets. Like the only weird part then is you have to think of the first bracket as having a times by 1 out in front. I hope we can see why that's really inefficient. 2m minus n, because if I multiply by 1, I don't change anything. And now you expand in a negative 1 and expand in a negative 1, and maybe that's where you can see when I expand in a negative, that negative times that negative gets me my positive. So perhaps you're using the blue method, and now you're collecting and saying 2m minus 4m, negative 1 plus 8. But I like the purple method better. So something to keep in mind as you go. Okay, I think question C becomes a great gauge for us on where are we at with simplifying. So I want you to go ahead and give C a shot. Pause the video now. Okay, we're back. Quick confirmation then. You notice you have an AB term, B term cannot collect, B term, AB term cannot collect. So we move on to that subtraction operation in between. Well, I have a 3AB subtract a positive 5AB. So I'm going to take 3 of something and I'm going to subtract 5 of something. That is a negative 2 of something. That's something. ABs. Then I'm going to take a positive 4B and subtract a 2B. Well, my 4 subtract my 2, there is a positive 2B. Okay, if you came up with that, great. I want to talk to you, though, about format. When you look at that purple expression can be simplified more. Since we take a look at that and we notice that there is no different degrees with respect to a variable, this isn't a b squared versus b term situation. So I get to this point, I can actually write that in a more simplified form if I change the order of my terms. I'm going to write my single b term first. Because it's positive, I do not have to write that sign. And now when I write my AB term second, you'll notice I got to write down fewer operations. In the purple, I had to put the negative term first. But because I switched the order and put the positive term first, that's technically more simplified. Okay, something to keep in mind as we move forward. Okay, let's keep it going. Okay, now we're going to start to get back up to some more complex expressions that you encountered last year. Okay, take a look at D. Let's see how we can do. Okay, pause the video now and give it a shot. Okay, we're back. So if we keep going through our bedmass process, we recognize cannot collect inside the brackets, so we move on to the next operation. The issue becomes we cannot touch that plus 2 yet. We cannot touch it. That plus, there's my addition. I have one term added to another term. The problem, though, is that term has multiplication in it that we can do. So since each one of those brackets has that coefficient, it's got a times by 3 on the front and a times by 2 on the front. Then BEDMAS would say, I have to do my multiplication before I do my addition. So what I'm going to do is I'm going to take that 3 out in front of the first bracket, and I'm going to do my multiply, which means I multiply it by everything inside that bracket. You know that as expanding. So I'm going to take a 3 times an x and a 3 times a negative 2y. You also should know that I can take this positive 2 and expand that into my brackets. And so when I do that multiplication, I'm going to take my 2 times my x and my 2 times my 4y. That was our expanding from last year. That is you using your distributive property. That is how I multiply in algebra. Now what you created was an expression we started with at the very beginning. Now let's go ahead and collect to do those operations. So I got a 3x plus a 2x. There is my 5x. And I have a negative 6y plus an 8y. There is my positive 2y. I lose $6. I find $8. I'm up 2. Okay, hopefully we match up. And I think we're at a point now where I want you to tackle both E and F, and then let's come back and check and see how well we did. Okay, I want you to pause the video now, give them both a shot. Okay, pause it now. Okay, we're back. So we take a peek. I cannot collect because I have A squareds and single A's. Same thing in the second bracket. So I can do my multiply. I'm going to expand my 5 in, and I'm also going to expand my negative 3 in. Okay, where does that get me? So I expand in my 5, and there's my 5A squared. Expand in my 5, there's my negative 10A. Expand in my negative 3, there's a negative 12A squared. And expand in my negative 3, there's my positive 9A. Be very, very careful. Easily the most common mistake, your negative times your negative, and you don't write a positive. There we go. Okay, one real quick thing for us to make a note of, and I'm going to blow this up on that first term. Down here below, you cannot simplify that term. Despite what you might think, that term itself is simplified. Make a note that that exponent of 2 is only on the A. So if I had to go and put brackets around that, it would actually be A squared. That squared has nothing to do with the 5. You can actually see that back up in the original. It was 5 times an A squared. So please make sure that there is no part of you that sees 5A squared and goes, hey, look, let me square the 5 and say that that's 25. How are you? You just broke bedmass and you're doing operations that have nothing to do with each other. Be careful. So you take a peek at that first term, 5A squared. It is fully simplified. So now let's go ahead and collect whatever we can. I got a 5A squared minus 12A squared. That's a negative 7A squared. And a negative 10 plus a 9 gets me my negative 1. Okay, 2 things in terms of form, communication. Number 1, because that expression has the same variable with different degrees, one's squared, one's a single A, then it is important for me to write that expression in descending order, write it in standard form. So this is not like the last case where we talked about what term you put in front to minimize operations. No, we are going to write the squared term first, the single term second. Secondly, do not write the number 1 in there. We know that there's a 1, but that's bad form. When there's a coefficient of 1, we do not write it. Okay, if we've got that, then I think we're doing great. Okay, you have a chance on that last one to get some confirmation and see how things are going. Okay, I take a look. I've got my 6x I need to expand in. I can already see that I'm not going to be able to collect anything on the inside because I have terms with the different variables, not even close to being like terms. So let's expand in our 6x. Just make a quick note, that first term better become an x squared. We are taking an x times an x. There's my x squared. Okay, now I end up with a 12xy. It's actually really easy to multiply variables that are different. You don't really have to worry about the exponents changing. Now I'm going to expand in my negative 5y. And so there's my negative 10xy. Okay, here comes another point where we need to talk. Look what I did naturally. I want you to do that naturally. It's also good form. If I chose to just simply write down that term in the order the variables were presented beforehand, I may have written down this, negative 10, yx. Now, it's bad form when you have multiple variables within a term to write the variables not in alphabetical order. You should always write them in alphabetical order. But secondly, for some of it, it's visual. Look at this term. That's an xy term. Look at this term, which is also an xy term. It might not jump out at you that it's also an xy term because the variables are written in different orders. That means collecting those terms later on might not be so automatic. A good habit to get into, but also one for proper form. Every time you write down a term, if it has multiple variables, write those variables in alphabetical order. It's proper form and it helps you identify like terms. Finish off your expanding, and hopefully we come up with that. And you notice that there's only 2 terms that can collect in that instance. I can't collect anything with those x squareds. I can collect the xy's, and I've got my y squared term. And if we got down to that for f, then I think we are doing outstanding. Okay, let's keep moving with getting back into some review stuff. I want to take a look at question 4, and I'm going to go through question 4 very, very quickly. I want to show you 2 different ways to go through it, because really it's 2 different strategies. You're going to notice that they're actually opposite each other. What question 4 asks you to do is to calculate that expression if x has a value of -1 and y has a value of -3. So what I could do is just do the purple. I could sub x equals -1 and y equals -3 into that expression. Now, what I want you to do on your page, put down a little wavy line right down the middle of it, because we're going to put down 2 different solutions for this. And I want to keep my entire first solution on the left side. So what I'm going to do then is I'm going to take that expression, therefore, 2 times, and I can make my substitutions into my variables. So that would give me a -1 squared minus a -3 minus 3 times 2 times my -1 squared plus my -3. And there is me making my substitution. Wherever I see an x, I replace it with -1. Wherever I see a y, I replace it with -3. Now I have an expression that's all just numbers. That's why I can calculate. Okay, if I was to ask you this question, I never need to see that first line. I would hope you would just calculate everything you can. So for instance, you wouldn't touch the 2 because we got to follow BEDMAS, but you can do the 1 squared. 1 squared is 1. It's not -1, because -1 squared means -1 times -1. And anytime I multiply something by itself, the same sign, my outcome is positive. It's also not 2, so be careful. Now I take a look at my next one. I'm going to subtract a -3, so I'm really going to add 3. Minus, I'm not going to touch that multiply until I do the operations on the inside of the brackets. Well, I'm going to get a 2 times a 1 again, my -1 squared, plus a -3. So if I add negatives, I subtract. There I am with everything as a single sign. Now, I don't know what you do. Just keep following BEDMAS. Maybe I simplify that inside to a 4. I don't touch that 3, but I can simplify the other inside, 2 minus 3. Now I can finally do my multiplication. My 2 times my 4 is 8. My -3 times a -1 is a +3. And we get down to 11. I don't know how many of those lines you would need to show me. I certainly would need to see all of those. Jump some lines. Do some mental math. It's good. Okay. That expression has a value of 11 if x is -1 and y is -3. It clearly has a different value if x or y start to change values. So what if I didn't want to build that big ugly expression at the very beginning? What if instead of substituting in on the blue line and then simplifying to get to the orange, I just flip that on its head? What if instead I simplify? So what I'm going to do is I'm going to take my original expression and I'm going to simplify it first. Okay, let's expand in our 2. Let's expand in our -3. Let's collect like terms. I've got 2x squared terms, that's a -4x squared. I have 2 single y terms, that's a -5y. That expression is now fully simplified. That's what I just did there. And now what I'm going to do is I'm going to do the blue. Now I'm going to substitute. By substituting now, then the only thing I had to do was sub x equals -1 in once and y equals -3 in once. So what that becomes then is a -4 times a -1 squared minus a 5 times a -3, of which a lot of people would skip that, and they would simply say -1 squared is 1 times -1. -5 times -3 is a positive 15. And there is your 11, and you are good. 2 different ways to go through that problem. I hope you like both of them, but it's good to have a preference on one of them. If I had to choose, I'd be choosing the red one. Okay, last problem. I want to jump into something that's going to be super useful for you. Take a look at problem 5. Problem 5 has asked you to list the prime factors of each of those numbers. And for some of us, we might need a little bit of a review on what prime means. If you recall, prime means that if you were to look at the numbers that multiply to give another number, a number is prime if the only factors are 1 and the number itself. So, quick review. 5 is a prime number because the only way you can write 5 as the multiplication of whole numbers is 5 times 1. 6 is not prime because, yes, it's 6 times 1. Everything is itself times 1, but it could also be 3 times 2. So 6 is a composite number. 5 is a prime number. So the instruction for the problem then is you have to list all the prime factors of 18. So what are all the prime numbers that would multiply to, that's what factors means, multiply to give 18? Okay, I could let you just go through, but I want to give you a format for it. Back in grade 4, you should learn what a factor tree is. And for some of you, you haven't really used one since. I happen to personally think that a factor tree might be one of the most important tools you ever learn. You want to put this in your back pocket. If I was to take 18 and I drew a little tree, so I'm going to draw 2 little branches. I'm going to break apart 18 into numbers that multiply, factors. And so maybe off the top of my head, if I said, hey, give me 2 numbers that multiply to give 18, you may go 9 times 2. And if you chose 9 times 2, then you can sit there and you can go, okay, 9 times 2, well, 2 is a prime factor, so that's nice. I have one. But 9 isn't. But if I factor 9 further, then I have 3 and 3. I can continue to factor down until I'm left with only primes. What you will notice then is that I could break 18 apart into a combination of 3s and 2s. So list the prime factors of 18. Well, the only numbers, prime numbers, that multiply to give 18 that are prime are 3 and 2. And maybe to get into a habit of writing them in increasing order isn't a bad thing, but it doesn't matter order. Okay, I want to quickly go through and say, but what if you didn't see 18 as 9 times 2? Factor trees are great because it doesn't matter. So let's say that I took 18 and instead I broke it up into 6 and 3. Well, 3 is a prime factor. 6 is 3 and 2. And you will notice that I eventually get down to the same thing, 1, 2, and 2, 3s. Factor trees are great. So what I want to leave you with are factor trees on 30, 72, and that huge 420 on the end. What I don't want you to do is use a calculator at any time. So work your way through those three. We'll come back and we'll confirm our list of prime factors in the end. Okay, pause the video now. Okay, we're back. So if I took a look at 30, my way of factoring would tend me to take a 6 and a 5. 6 is 3 and a 2. And I can see my list of prime factors, therefore 2, 3, and 5. Let me take a look at 72. 72 starts to get a little bit bigger, and for some of us, because 72 is bigger, we might cop out a little bit and go, oh, well, I know it's even, so like 2 goes in. But then it does force you to work with some bigger numbers. Like, that's okay. 36 is a 6 and a 6, or 36 is a 12 and a 3, or 36 is a 9 and a 4, like whatever combination. For me, I see 72, and I would love for you to see that as a 9 times an 8. You break down 9, and maybe you don't even go any further, because you can already see that 9 is 3 squared. You take a look at 8, and here's where you may go, 8 is 4 and 2. Here's where I would love you to go. 8 is 2 cubed. 8 is only made up of 2s. And so even though our number 72 keeps getting bigger and bigger, our only 2 prime factors are 2 and 3. Okay, we jump into D, 420. So I break that apart, and I would love it if everybody's first one was that. Like, I see that the number ends with a 0, so I know that 10's a factor. And as soon as you do that, you break it down pretty quickly. 42 is a 6 times 7. 10 is a 5 times a 2. 6 is a 3 and a 2. And so if I finish off my prime factors for that, I can see that I have a 2, I have a 3, I have a 5, and I have a 7. And there we go. Okay, I'm hoping that today's video got you back into the swing of some of your algebra review. We reviewed what simplifying means, and today becomes an opportunity to get back into shape of you getting used to working through your algebra. Okay, jump in and get some practice. Best of luck.